This is a functional RC plane, and today I'm going to be showing you how I made it so you can make your own for the Ontario Aerospace competition. Before we even get started building a model plane, we need to quickly go over model plane restrictions in Canada. If your plane weighs 250 grams or more, which it most likely will, it falls under the small drone category, meaning you will need to get a drone pilot certificate to fly it. Quickly head over to Transport Canada's website by typing in RPAS certification and get the basic operations certificate by passing their online test. This will require you to do a little bit of studying, so make use of online guides to get the important details down and then keep the resources open in case questions arise which you forget the answer to. Taking the test will cost $10 per attempt, and once you get your certification, registering your plane or drone will cost $5. Now with that out of the way, let's check out what parts you'll need. The tools you'll need may vary from plane to plane, but you will always want to have access to these essential ones: a hot glue gun, an X-Acto or hobby knife, packing tape, some marking tools, and a set of screwdrivers. With that out of the way, let's talk about the actual parts you'll need to build an RC plane, starting with the electronics. For an RC plane, you'll need a battery, receiver, ESC, transmitter, motor, and servos. And if you're wondering about how to get these parts, everything I use is available for purchase at Great Hobbies. Another thing is that building planes can get a little costly, so if you want to save on your parts, come over to their Mississauga location on Sundays and look for me because I'll give you the friend discounts. My name is David, by the way. Anyways, at the most basic level, your transmitter sends a signal to the receiver which tells the servos and motors what to do. However, you might be wondering why there is a speed controller, and that's because the motors you will use are brushless, which require a dedicated circuit to control their speed. Additionally, the battery will be connected to the ESC, so you must make sure it can deliver power to the receiver and the servos through a BEC wire. This wire will also allow the ESC to talk to the receiver so it knows exactly how much power to deliver to the motor. As for the servos, their job is to move the different control surfaces on the plane. Your standard RC plane will have 3 of these control surfaces: the ailerons, elevators, and rudder, which along with your motor will give you 4 channels of control in total. The easiest way to know if your parts will fit together and also work together is by asking your local hobby store or giving us a message, but I will also be posting a Google Doc with some basic information about some general parts to get you started. As for the rest of the plane, it will mainly be built of foam board with some miscellaneous parts that I will cover throughout the tutorial. With that being said, let's get to the building. Before we get started, I want to cover some basic foam cutting techniques. If you get the correct foam board, you'll notice that it's basically a sheet of styrofoam sandwiched between 2 sheets of paper. This is important because there are different ways we will be cutting the foam board in order to make this plane. The 3 types of cuts I want to cover in this tutorial are the regular cut, the score cut, and the bevel cut. I highly recommend you practice with a small piece of foam board before you get to cutting the actual parts of the plane to make sure you are cutting correctly. So without further ado, let's get started. A full cut is essentially just slicing through the entire foam sheet so that the 2 sections of foam separate from each other. You must cut all 3 layers to do this. Next, a score cut is when you cut through the top layer of paper and a little bit into the styrofoam so that you can then fold it into a hinge. This is important because we are making moving flaps, which need to remain attached to the main wings but are able to move up and down. This then leads me to the bevel cut. In the bevel cut, you take your foam hinge and cut the styrofoam edges at a 45-degree angle. This will allow the flap to move both up and down, and it can also help you make 3D shapes, such as a frame, by folding these sections into each other. Now with that out of the way, let's get on to the building. So here's the diagram for the main wing, with all the measurements in inches. At this point, feel free to pause the video and draw it out on your sheet of foam board if you want to make this exact plane to practice. For those of you making a different plane design, please note how I use the different types of cuts to make the aileron hinges as well as the airfoil. Speaking of which, I will be shaping the wing into this KF airfoil, which is really just for a little extra lift at slow speeds. This is very easy to make as you just make a score cut and fold the wing on top of itself like this. So as you can see, I've created the basic shape for the KF airfoil right there. And now I'll be cutting into the other lines to make the ailerons.
So now you can see we can move these ailerons. So we have our airfoil here, and then these ailerons move. So now I'm just going to make sure that they can also go down. That's what I'm going to do now.
And now I'll be making the 45-degree cuts to get our bevel cut in our plane. Notice how I use the knife at an angle so that we can get an easy cut and a clean cut without breaking any of the paper that's supposed to remain attached.
You can see over here, I cut a small hole, but I didn't cut through the paper, so it's still attached here. And what we're going to do is we're going to go over it with a piece of tape after to reinforce it. But that's how I make my control surface. It's just one piece of paper holding these two foam pieces together. And they can move up and down because there's no foam here. And the last thing I'm going to do is just cut a little bit on the side so that there's space for this to move without hitting the foam board like that. Alright, so now this is what your finished aileron should look like. Basically it's just going to really go up and down like this. Now let's do the other one. So I'm going to take this tape. So while it's completely folded, you want to put the tape so that it goes like this and perfectly on the surface, then on the next surface here, and on the other side. So now it's a little bit more reinforced. It's a lot harder to break this part, and it can still move up and down. So let's do the same thing for the other side. Now, this is what your wing will look like from the top. So as you can see, it's just the airfoil here. It's just like a little step, if you can see that. And then the ailerons at the back. Now, we're going to have to glue this down. Okay, so now that our hot glue gun is warm, you're going to want to pass a line of glue all the way down. And then we want to go on this edge here. And there, now we have a pretty well stuck airfoil. So that's our main wing finished. So now let's move on to the rear wings.
Here's the diagram for the horizontal stabilizer and the vertical stabilizer. Make note of all the score cuts in both sketches so that you can see how the rudder and elevator will move. Also note the way the elevator is meant to fit within the rudder to allow the elevator to move inside of the rudder.
So now we have our elevator here, and we're going to put some Scotch tape on it, as usual, to reinforce it just a little bit. So yeah, that's our elevator. So now I'm going to leave this to the side, and we're going to build our rudder.
So now you can see I've built both the horizontal and vertical stabilizers, and I'm going to fit them together to show you how they work together, just like I showed you in the Fusion 360 model. The reason why the elevator was made to fit within the rudder was to be able to attach a wheel at the bottom of the rudder to make the plane steerable. This will make taxiing, taking off, and landing much easier. Here's the diagram for the fuselage. You need to make sure the fuselage is a hollow tube of some sort so there is space for all the necessary electronics. Additionally, I've decided to taper off the back end of the fuselage just so more weight is at the front. The wingspan on a slow flying plane will usually be longer than the fuselage, but the best way to figure out proper proportions is to check online for existing planes that perform the way you want your plane to. As an example, faster flying planes will have shorter wingspans relative to their fuselage. Now, once you've cut out your fuselage, you're going to have to add bevel cuts on each of the dotted lines so you can fold it into the tube shape and glue it together at the joints. For this specific plane, I will also be adding a slit that the vertical stabilizer can slide into.
Okay, so what I have here is just a basic motor with a 3D printed version of the flight test firewall. And essentially what this does is it just helps us put the motor with screws into these holes, as you can see here, and then we're going to attach it like this with hot glue and some tape. The way you'd use this if you did buy one of the flight test kits is you just put one wire in at a time, and then you gotta just squish it. You gotta squish the wires so that now this will fit over the spools over here. And I'm just gonna screw this in now. Alright, so here we go. So now this is our motor before being mounted, and you can see that these wires will go into the fuselage as we put this motor in, like this. But before we glue it on, let's just get a speed controller attached to it, because that way we don't need to worry about it. And before we do this, let's test out which direction the motor is turning. So if you see this propeller here, you can see that this is the front side. The front side is where the numbers are, and you always want it to spin where the upper, so towards the upper end. So you can see how it's going to take in air and push it downwards. So you always want to spin in this direction. This direction will generate dust this way. So this direction is counterclockwise right now. So let's see if this motor is spinning counterclockwise when we turn on the remote. And you always want to connect these up before you attach them onto the fuselage, because if you've got the wrong connections when it's already attached, you're going to have to figure out a way to flip them around. So let's see if it spins. So right now it is spinning in the correct direction, but let's say it wasn't. Let's say it's spinning clockwise. Then I would take these two wires and just switch them. You take any two wires and you switch them. And as you can see when I spin it now, it's going to spin clockwise. We can drop everything into here, and then put this like so. To access our electronics later, we're going to cut open a hatch, but for now, let's put this motor on. So we want to make sure this is perfectly centered. It's easy to do because we already made a frame that fits this motor mount perfectly. So now what we're going to do, we're going to get our glue. So now we have our motor mounted, and next we're going to put the wings on. Here we go. You can see it'll align perfectly. And then we can also make sure that it's straight by looking on my back markings, which are in the same spot, because you want to make sure your wings are straight.
So here's basically the diagram for how you should be gluing the wings in this specific plane. Again, please refer to actual existing designs if you plan on making a different plane so that you get the proportions right, because every plane is different depending on what performance you want to get out of it.
So yeah, that's how we attached our front wings. And also I have this landing gear. So what's important about the landing gear is that you should probably think about buying ones from the store, because making them yourself with music wire, which we're going to cover later, is not the best. They usually are pretty flimsy. So I have these that I bought from the store and a fitting that I'm going to use so that they can't move, and then I'll stick this end onto the plane. So now as you can see, we have our landing gear, and our plane is finally starting to take shape. So before we continue, we're gonna open our hatch up. And we're gonna need our hatch to connect all our electronics. Now we can fold this up, and as you can see, we get access to the area where we're gonna put our electronics. And it's okay to add more than one hatch. You just have to remember to seal it up before you continue. We're probably going to fit our horizontal stabilizer angled downwards. When this plane tries to lift up, this will give it some downwards force here. Alright, and now we have to put this in, like so. So now you can see that the top part is going straight down the middle, and we can actually push it a little bit more till the end there. So you can see that this will be able to turn, and this will be able to turn, and not this part. This part will be glued. So here we have our servo, and basically the way we connect our servo to, let's say, our elevator is through these wires. And what happens is, when the servo turns, it'll push a wire that will be connected to the elevator that will push the elevator up and down, or the rudder up and down. So the way we want to do this is, first we want to grab something that we can put on the elevator that will hold the wire in one of these little holes. And now we've sealed in our servo. So the next part, what we're going to do is we're actually going to just cut the receiver hole. So we saw how far the servo went. It went to about here. So we can cut a hole around here to put the receiver and all the other electronics and make it easy to access. Alright, as that's sticking, you can see our ESC wire. So we're just going to plug this into, for my receiver it's channel 3, that's the throttle channel, and if you get a FlySky receiver, it will also be the same. Make sure that the yellow wire or the signal wire is facing upwards. And then the same, this servo is going to be our elevator servo, so it's going to go into channel 2. You can see here that since the servo is now centered, we can take our servo arm, which I appear to have lost. Okay, we can take our servo arm here and put it in the position we want to put it, because the servo is already centered. So we can take our servo arm like this. Let's say this is what we want our starting position to be. So now, what I'm going to do is I'm going to take this control horn here and just put it so that it'll be on the edge here. So we're going to put some holes inside of the elevator and glue this in so that it's in this position. So when it pushes and pulls, it'll go up and down. So let's do that right now. And yeah, let's just wait for it to dry and continue. Alright, so the next step probably the hardest part of this entire build, and that will be to get the control horn to be the perfect length to go from the servo to this control horn, and it has to be the perfect length so that it's centered when everything is in the neutral position. So to do that, let's get some pliers. This is 1mm music wire by K&S if you want to find it on Great Hobbies. And what we're going to do is we're going to do our first bend here. So this bend is going to be like a 90-degree angle, if you can see that. Then we're going to take our pliers again and we're going to do another bend so that it becomes a bend like this. Now this is important because when we're putting this in the control horn, this is what it's going to look like. So if you can see, I'm going to take out my servo arm for a second. The servo arm will go in through here, and this will be the resting position of the servo arm. So when it pulls, it'll pull it and push it, but this can't fall out at all. It has to like twist to fall out, and the servo can't do that. And the wire also can't do that because it can't twist downwards because there's another point of contact holding it here. So now that we have this part ready, we're going to put this, let me show you here, we're going to put this onto the servo into the position we chose, and then we're just going to take a rough measurement of where this is going to be on the control horn when it's in its neutral position. Like that. So now it's secured onto here, and this end can be secured onto the servo. So now we have a servo that when it moves, it'll move our elevator. You can see that the music wire is attached through there, and it goes all the way over to this control horn on the elevator. So you can see how that also goes through there. So that's what you want to set up. And basically when I move the servo arm here, the elevator will go up like that. And then when I move it again, it'll go like this. Alright, so for the ailerons, you either have two options. Option one is to put two servos on each wing, or one servo on each wing, and each servo independently controls the aileron. So this one would control this one, and then on the other wing there would be another one. Or you can put it in the center where it controls both. By just holding two music wires and pulling each one. Alright, and then setting up this aileron, we're just going to again put this on like so on here, and we're going to take one of our control horns, take it on like this, and then for this one we're just going to line it up like this again. Alright, so there we go. That's one of our control horns done. Alright, so as you can see, now we've hooked up the aileron servo over here with a push rod or music wire all the way to the control horn. But now we have like a basically perfect connection, and we've also done it on the other side over here. To connect both of these servos to one channel, we're using this Y plug, which takes both the servo wires and converts it into a single wire that we then plug into channel 4 of our receiver. And now you can see that when we move the stick, the ailerons will move. And since we already have the elevator hooked up as well, you can see that it moves the elevator as well. And of course, we move the motor. So you can see we almost have all of our electronics set up. Alright, so now we have basically every control surface on the plane set up. We have our rudder servo here. On the bottom we have our elevator servo, which is connected to the bottom of our elevator here. And we obviously have the two ailerons right there. Alright, so first we're going to pull down. We're going to see the elevator move. It's going up and down. And then moving this stick left and right, we're going to see the ailerons move. And then finally, moving the first stick left and right, we're going to see the rudder move.
Okay, so here I just grab a random plastic circle that I found. This is actually a prop adapter, and I stick it between two control horns using a music wire, and it's really scuffed, but it works really well.
A U with the music wire, and then we have the little wheel and these two control horns on each side holding the wheel in the middle. And then we're going to attach the control horns onto the rudder, like so. You can see it's going to attach like this. So then we have the wheel at the very tip of the rudder, which will give us steering. We have our rudder wire, our elevator wire, our motor wire, and our ailerons wire. Basically what I'm going to do is I'm going to put the receiver inside the plane like it would be if we were going to fly. So I'm going to put it in the hatch. Alright, so now it's inside the hatch there, and I haven't put any tape or Velcro on it, and the reason for this is because in case we need to check if something is working later or switch out some electronics, it's a lot easier to just have it there so we can just pull it out instead of like taping it down or anything like that. So I like leaving my receivers like this. If you have a bigger fuselage where it can move around a lot, then I do suggest Velcroing it just so it's still removable. So now we have this in place here. All of our connections are ready. And the last thing we're going to do is just test for the center of gravity. So we're going to take our battery, and our battery is the biggest weight on our plane. So we're going to be moving it around and seeing where we should put it so that the center of gravity is correct. And usually the center of gravity is correct when it's in between, when it's on the main wing, on the first quarter or third of the main wing. So if it's anywhere around this area over here, so if it's like, let's say where the center of gravity is here, if it's anywhere in this area, in this range, that's a good center of gravity.
To test the center of gravity, you need two sticks to balance the plane's wings onto. I got lazy and used my fingers, but to be exact, you can use two pencils instead. If the center of gravity isn't around 1/3 of the way from the front of the wing, then you can reposition the battery or add some extra weights that I'll cover right now.
Alright, so another handy tool to have is lead weights, because especially for lighter planes, it's hard to get the center of gravity right because motors are really light, speed controllers are really light, so most of the weight is in the foam. So I'm going to take these lead weights and fix the center of gravity so that it's correct.
The last two things we need to do before we fly are attaching the prop and closing the hatches with tape or Velcro. Every motor has a different mounting system, but the important thing to consider is to make sure the propeller has the right bore size to fit on the shaft. Some props will not need an adapter, but mine from APC thankfully came with one because it was originally too big. The specific mounting system my prop used was an external piece that tightened onto the motor, but some motors just have a bolt that holds the propeller. With that out of the way, just tape down your hatches and you'll be ready to fly if the battery's plugged in, of course.
Alright, so with the prop installed, we're basically ready to fly.
Before going out to fly, always make sure to test your control surfaces first so that once you get in the air you'll actually be able to fly properly. For your ailerons, when you move the stick on the right to the right aileron should go up and the left aileron should go down, and reverse if you go to the left. For your elevators, when you push your right stick down, your elevator should go up, and when you push your right stick up, your elevator should go down. For the rudder, when you push your left stick left and right, the rudder should also follow in the exact same direction. So left goes to left, right goes right. And for the motor, test it by pushing the left stick up while holding onto the plane so it doesn't move away from you. If the motor can go up to full speed, then all your control surfaces will be working. Since you made it this far into the video, it's time for the outro. While you watch the plane, I just want to thank you on behalf of the entire team for being a part of this event, even if that's just watching the plane, even if that's just giving some likes on some Instagram posts. We really hope you can share this with as many people who might be interested as possible so that we can make this event happen and make it as successful as possible for those who want to explore aerospace more deeply before they make it to university. We hope that you found this video helpful and welcome your feedback because the next few videos are in preparation and are going to be posted soon. Make sure to give us feedback as well on our website, our Instagram posts, and anything we make in the future because that'll help us make this event as great as possible and bring it to as many people as possible. Thank you so much for watching, and if you haven't already, check out all of our socials and stay tuned for further event updates and tutorials.